Okay, the grain bin below is made up of a cylinder and a cone. To the nearest cubic foot, how much grain will this bin hold? Use pi equals 3.14. So we need to find the volume of each of these, the cylinder and the cone. So we're going to find the volume of a cylinder. Oh, can you not see that? Oh, sorry. Okay, volume of a cylinder. We're going to find the volume of the cone. We're going to find the volume of each piece and then add those volumes together to get the total volume. So volume of a cylinder, you would look at your reference sheet. Volume of a cylinder is volume equals area of the base times the height. Never. And then volume of the cone, again, reference sheet, 1/3 area of the base times the height. 1/3 area of the base times the height. The area of the base is the base is a circle, so area of a circle is pi r squared times the height, and then for the cone, 1/3 pi r squared for area of the base times the height. Okay, now we start plugging numbers into the equation. Volume equals, it says T is 3.14 for pi. And then the radius of this shows the diameter is 30, so radius would be 15 squared. And then the height of the cylinder would be 20. Then you'd plug this in a calculator, make sure to square the 15 first, and you get a volume equals 14130 feet cubed. And then for the cone, same idea, 1/3, 3.14 for pi. Radius is 15. And then the height of the cone, 35 minus 20 is 15. So that's the height of the cone right here. Like that. Okay, then you'd put this in a calculator, make sure to square the 15 first, and then you could do 1 divided by 3 times 3.14 times 225 times 15, and it comes out to 3532.5. Okay, and then we have our two volumes here, but it wants to know the total, so we add those two together. And it comes out to 17662.5. Next. Okay. Hannah cut a quadrilateral from a piece of cardboard with the diagonals having the following characteristics. What type of quadrilateral must Hannah have cut out? So quadrilaterals, 4 sides. It says the diagonals are congruent, perpendicular, and they bisect each other. The only quadrilateral that has the diagonals that are the same length, they're perpendicular, is a square. So square. So it have the 90-degree angles, and then all the sides are equal, and all that jazz. Okay, 45. What is a contrapositive of the statement below? So we have to remember what contrapositive is. So we're going to write out the chart, and hopefully at this point you kind of have it memorized. So conditional, converse, inverse, contrapositive. And I have this order memorized, and I also have this order. So P then Q, Q then P, not P, then not Q, and then not, make sure you get it, not Q, then not P. What's that, Philip? Oh, yeah? Okay. However you can memorize it, but writing it down, I can write it down, and then I can use it. So contrapositive, not Q, not P. So in this conditional, this is P and Q, so not Q. So it does not have two congruent sides. And then not P, not isosceles. So this is the answer I'm looking for. Okay, so it's A. Thank you, Philip. Okay, next question, 46. Number 46, you have this trapezoid. It wants to know the length of this dotted line right here, so this will be x that we're trying to solve for. We're going to use trigonometry. So we have our angle here, and then we have the adjacent side and the hypotenuse, and then SOHCAHTOA, adjacent and the hypotenuse, we're going to use cosine. So cosine of 35 adjacent over hypotenuse. Then once we have it set up, we're going to solve for x. Because the x is the denominator, it takes an extra step. So multiply both sides by x. We get x cosine 35 equals 170. Divide by cosine 35. Divide by cosine of 35. And then this divides to, what's my answer here? Divides to 207.53. Okay. Next. Keeping up with me? Okay, 47 is one of those that's kind of like a puzzle. You have to fill in angles, but it's not too difficult. It says using the figure below, what is a measurement of BAC? So we're trying to find this angle right here. So let's see what we have. We're just going to fill in angles till we get that angle. So these are supplementary. So I can do 180 minus 115 to get that angle. And that would come out to 65 degrees right here. And then to get this one, these three angles would have to add up to 180 because it's a triangle. So 180 minus 53 minus 65 comes out to 62 degrees. So this is 62 degrees, and that is my answer. Next. This one's really popular on testing. It's called concentric circles. It wants to know just the shaded part area. So we have to find the area of the larger circle and the smaller circle, subtract them, and it'll give us just the shaded part. So we're going to find the area of the big circle and the small circle. And it says to use 3.14, yeah. And then we have to find the area of both. The area of a circle, pi r squared. That's on the reference sheet if you need it to. And so area is 3.14. The radius of the big circle, it shows as 6. So 6 squared equals 113.04. And then the small circle, and then to find just the shaded part, we have to subtract them. And it comes out to 84.78. How many questions are we doing? We're doing 21, so yeah, I don't know where that is. 49. The net figure can be folded into which of the three-dimensional solids? In this case, like, I don't know if you can see it, it would make a triangular prism. A triangular prism looks like this with like rectangles like all the way around. So if you folded up these two sides, yeah, it would make a triangular prism. The other one that might trip you up is triangular pyramid, but a triangular pyramid would have a triangle base and then like triangle sides like that. So that would be triangular pyramid. The other ones don't really make sense at all. Okay, 50. This one threw me off a little bit. Two tetrahedra are congruent. One tetrahedra is glued to the other so that the glued faces of the two tetrahedra completely cover each other, producing a new polyhedron. How many faces does the new polyhedron have? Okay, first of all, we have to figure out what a tetrahedra is. And I have a visual around here somewhere. Yeah, where's my paper with the... It's around here somewhere. Oh, here it is. Okay, just let me... Tetrahedra. right here. It is a shape with 4 triangles. So it's like a triangular pyramid. So it has a triangle base and then it has 3 triangles up at the top. So I'm going to try to draw one. So here, a triangular pyramid, triangle base, and like 3 triangles all the way around. It says 2 tetrahedra are sharing a side. So let's say they share the bottom. We got this. We have to figure out how many faces that would be exposed. So you have the 3 around top and then the 3 around the bottom. So that would be a total of 6, yeah. Let me just get through this build. Okay. 51. If PQRS is a rhombus, which statement must be true? Okay, for rhombus, all the sides are the same. Did I skip something? No. Okay. 51. For a rhombus, all the sides are the same length, and then the diagonals of a rhombus make a 90-degree angle. And let's go through the answer choices, see what works. So PSR is a right angle. Nope, PSR is not a right angle. We can even see that right away. PR is congruent to QS. PR congruent to QS. No, the diagonals are not congruent. PQR is congruent to QRS. No, they're supplementary, but they're not congruent. And PQ equal to QR, correct. They are the same length because in a rhombus, all the sides are the same length. Next. The measure of each exterior angle of a regular polygon is 45 degrees. How many sides does a polygon have? Okay, exterior angles equal 360 degrees for any polygon. So they always add up to 360. So if we take 360 and divide it by 45, we can find out how many angles it has. This comes out to 8 angles, and the number of angles and number of sides is the same. So that would be an octagon, 8 sides. Thank you. Next. Okay, here it says that K is parallel to M, parallel to N. Which statement justifies a conclusion that 1 is equal to 2 equals 3? Well, these are corresponding angles. So I'm looking for the answer choice that says that. So alternate interior, nope. Vertical, nope. Alternate exterior. Corresponding angles, D. Thank you. Next. C. Muy rápido. 54. So this is the conditional, inverse, converse, all that jazz. So remember the statements are this. I'm not going to have you write them again, but we're looking for inverse, which would be not Q to not P. Not Q to not P. Wait, did I? Actually, this is why you should write them again. Not P to not Q. Did you mess up? Okay, not P to not Q. So not rectangle, not parallelogram is what I'm looking for. C. Next one, 55. Which parts must be congruent to prove that these 2 triangles are congruent by side angle side? So for side angle side, it needs to be like consecutive side angle side. So for example, this shared side is the same. So we could say that this angle is the same as this one, and this side is the same as this, and we'd have side angle side. Side angle side on both. Or we could say that this angle is the same as this, and these 2 sides are the same, and we have side angle side, side angle side. So we're looking for one of those 2 scenarios. We know that this is the same as itself because of reflexive property. So here it says Q is the same as S. I'm going to erase these marks, by the way. QP is the same as SP. That would give us angle side side, and ASS is not a congruent statement. Nope. This one, Q equal to S, and then QR equal to RS. Again, you have ASS, but that's not a congruent statement. I'm going to keep erasing, so if you don't want to erase, that's fine. And then C, QRP is equal to SRP, maybe, and then I'm looking for this one to be equal to this, but it says QP equal to this. Again, angle side side, ASS, nope, not C either. D, QPR, this angle equal to SPR, and then QP equal to SP. Now you have side angle side, side angle side. Yay! D. Okay, 56. It is a dodecahedron. Okay, dodecahedron. I don't remember this coming up in the textbook, but apparently it comes up on testing sometimes. A dodecahedron is 12 faces. 12 faces. How many edges does a solid have? Well, here's the equation for it. You can take the number of faces, times it by the number of sides of each face. So there's 5 sides, or 5 edges per face. How many edges does a solid have? Then you can divide this by 2, and it'll tell you how many edges the whole solid has. So 12 times 5 is 60. Divided by 2, we get 30 edges for the whole solid. And that's just the equation. Next, 57. Enough. Just keep swimming. Okay. 57. What is the missing reason for the proof? For this, we're looking for this last reason. What I'm going to do is like mark all this up so I can see what it's looking for. So here it says ADB is equal to CBD right here. And then ABD, so this angle is equal to CDB right here. And then it says DB is equal to itself as a reflexive property. And now we're looking at why these two triangles are congruent. Angle, side, angle, angle, side, angle. So that is what we're looking for. Next. Okay, 58. For this, it wants to know this length right here. So this is our x. Let's see. So for this angle, we're going to use SOHCAHTOA. This angle, you have opposite and adjacent. So, okay, just one thing at a time. Opposite and adjacent. Tan of 60 equals x over 97. Then multiply this by 97, multiply this by 97. 97 tan of 60 equals x. X equals 168.01, and that is our answer right there. Next. Okay, I'll get it in the end. Okay, another one of these conditional statements that says, what is the inverse? The inverse, again, not P to not Q. So I'm looking for not pentagon, then not 5 sides. That's what I'm looking for. So, D. $60 right here. For this one, it's another proof one. We're looking for this blank here. So based on this, it's saying like this side is equal to this is equal to this, and of course the shared side is equal to itself. They're congruent because of side, side, side. Cool. And then it's saying that angle B is equal to angle D. How are they able to say that? They're able to say that because since the triangles are congruent, then all the angles would also be congruent. And that was CPCTC, or corresponding parts of congruent triangles are congruent. And the answer here, corresponding parts of congruent triangles are congruent. That means if you have congruent triangles, all their parts are congruent, all their angles and all their sides. Okay, 61. We have a triangle here. In the diagram below, triangle ABC. AB is congruent to AC. It's an isosceles triangle. In an isosceles triangle, not only are these sides the same, but the angles opposite are also the same. So this angle is the same as this. It wants to know the value of x. Since these angles are the same, this x plus 20 also applies to this angle. And then these three angles add to 180. So x plus 20 plus 3x plus x plus 20 equals 180, and we can solve for x. Combine your like terms. X equals 28. Okay, next. 2 more. This one, another one of those like conditional things. Converse is Q, then P. So George gets candy, then Bob does his homework. So that's what I'm looking for. A. Then 63, last one we're doing today. It says triangle PQR, and it shows these side lengths. Which statement about the angles must be true? So the only way to do this is to draw the triangle PQR. And then I'm going to label the sides. PQ is 8, QR is 12, and RP is 13. And then remember, the angles opposite these sides correspond. So like the shortest side will have the smallest angle. So this will be the smallest angle over here. And then the medium length side will have the medium angle across from it. And then the longest side will have the biggest angle. So small, medium, large, or big. And the answer choice that goes along with that is A. And that is all.